Hey guys, today we're going to do 4 AP Physics B problems. These are for electric circuits. So the first one is from 2002. It says 3. It's number 3. It says 2 light bulbs, one rated 30 watts at 120 volts, and another rated at 40 watts at 120 volts, are arranged in 2 different circuits. A. The 2 bulbs are first connected in parallel to a 120 volt source. Determine the resistance of the bulb rated 30 watts and the current in it when it is connected to this circuit. So first you want to use your power formula. And for this, it's power equals V squared over R. You'll manipulate to get R equals V squared over P. P. So you'll do 120 volts squared over your power, which is 30 watts, and you'll get an answer for the Roman numeral 1, 480 ohms. Now to find current, you'll do I equals V over R, which equals 120 volts over the 480 ohms, and you'll get 0.25 amps. Now, part B, Roman numeral 2 is asking the same thing, only with the 40 watts. So you're going to do the same. P equals V squared over R. Manipulate, and you get 120 volts squared, only this time 40 watts. That gives you an answer of 360 ohms. Now, to find the current, you'll do the same thing, only this time with 360 watts, and you get your answer to be 0.33 amps. Now it says, the bulbs are connected in series with each other and a 120 volt source. Roman numeral 1 is to determine the resistance of the bulb rated 30 watts and the current in it when it is connected in the circuit. Alright, we'll do that part down here. Resistance is still the same as it was in part A. So 30 watt equals 480 ohm. Your 40 watt equals 360 ohm. For series, instead of 1 over the resistance, you'll add them. So your total resistance is 840 ohms. Next, it wants the current. So you'll do I equals V over R, only this time you'll do it with the total. So 120 volts over 840 ohms, and that'll give you 0.14 amps. And it is the same throughout in a series circuit, so for the 30 watt and 40 watt, that's what you'll get. So, okay. Now part C. In the spaces below, number the bulbs in each situation described in order of their brightness. 1 equals brightest, 4 equals dim. Well, in parallel circuits, you'll get brighter bulbs. So, and then the one with the more wattage will give you a brighter bulb. So, this one will be 2 and this one will be 1. And in a series circuit, the one with the lower wattage will be brighter because it has a lower resistance. So it's 3 and 4. Now part D. Calculate the total power dissipated by the 2 bulbs in each of the following cases. Roman numeral 1, the parallel circuit, and Roman numeral 2, the series circuit. So we'll do that over here. Well, your total power is 70 watts, since you have the 30 and the 40. And your R total is 1 over 480 ohms plus 1 over 360 ohms. And at the end, you get 206 ohms. Then you'll do P equals V squared over R, which equals 120 volts squared over 206 ohms. And that'll be equal to 70 watts. Now for part B, Roman numeral 2, wants it in the series. Your total R total for that was equal to 840 ohms. So for this one, you want to do same thing, V squared over R, which is equal to 120 volts squared over 840 ohms, which is equal to 17 watts. That's it for part D. And that's the 2002 AP Physics free response. The next question is the Form B of this. So, of this year. It says, light bulbs of fixed resistance, 3 ohms and 6 ohms, and a 9 volt battery, and a switch S are connected as shown in the schematic diagram above. The switch S is closed. First, it wants the current in bulb A. So for this, first thing we'll want to do is, that's a parallel circuit in series. So we'll want to get rid of that by doing 1 over 6 plus 3, and that'll end up giving you 2. Then you'll do 3 ohms plus 2 ohms plus 5 ohms. And then to find current, all you have to do is V over R, so 9 volts, 5 ohms equal 1.8 amps. Next, which light bulb is brightest? Justify your answer. The brightest light bulb will be bulb A. Bulb A. It has the total current through it. B has 2/3 of the flow of the current flow through it, and C has 2/3 and B has 1/3. Mathematically, that's for B equals 1.8 over 3 squared. This is for I squared equals times R times 6 ohms. That one will have 2.2 watts. C has 1.8 amps divided by 3 squared times 3 ohms equals 4.8 watts. And A equals 1.8 amps squared times 3 ohms. It gives you 9.7 watts. That's why bulb A is the brightest. Now it says, switch S is then opened. By checking the appropriate spaces below, indicate whether the brightness of each light bulb increases, decreases, or remains the same. Bulb A will decrease because the resistance increases, power decrease then. Bulb B, it will increase because as the current will increase, power will also increase. And bulb C will decrease. So the switch is now opened, so current is 0, so the bulb is off. And that's it for the 2002 Form B. Now, the 2007 electric circuit question. The circuit above contains a battery with negligible internal resistance, a closed switch S, and 3 resistors, each with a resistance of R or 2R. Rank the currents in the 3 resistors from greatest to least, with 1 being greatest. If 2 resistors have the same current, give them the same ranking. So first, you have a parallel circuit and a series circuit. Most of the current will go through the first resistor. That's 1. And then when over here at the junction, the current will divide into 2. And that will end up with this having the least current and this having more. This is because A gets total current, B and C get divided current, but C has lower resistance, so it gets more current. Next it says rank the voltages across the 3 resistors from greatest to least, with number 1 being the greatest. And if the same rules apply, so if resistors have the same voltage, give them the same ranking. This is part B. The first one will have the most voltage because it has the most current, and because in a parallel circuit, voltage stays the same. So you have 2, 2. So let's write that down. A has most current, so most voltage. B/C are in parallel, so V is the same throughout. Now, it says for parts C through E, use E epsilon equals 12 volts and R equals 200 ohms. Calculate the equivalent resistance of the circuit. So first, 12 volts. Now this is 400 ohms, 400 ohms, and 200 ohms. To calculate the equivalent resistance, first you want to get rid of the parallel. So you do 1 over 400 plus 1 over 200, and you get 400 for 3, so you get 133 ohms. Now you'll add that to 400 ohms, and you get 533 ohms. Now D, it wants the current in resistor RC. And this is part D. So first you'll find your total current. Well, let's do this here. So 12 volts over 533 ohms. That gives you 0.0225 amps. Next, you'll want to do the voltage of A. Voltage of C equals epsilon minus voltage A. So you'll end up with E epsilon minus IA RA is then equal to 12 volts minus 0.0225 amps times 400 ohms, and put an answer of, I believe, 3 volts. Now to find in C, I see you'll do 3 volts over 200 ohms. Should get 0.015 amps. Now, the switch S is open. Resistor B is removed and replaced by a capacitor of capacitance 2.0 times 10 to the negative 6 farads, and the switch S is again closed. Calculate the charge on the capacitor after all the currents have reached their final steady state values. So, because resistor B is moved, you now have a series circuit. So, our total equals 400 ohms plus 200 ohms equals 600 ohms. Next, you'll do, to find your I current, because you want the current over here, so you could figure out the capacitor there, which is now here. So you would do 12 volts, I equals 12 over 600 ohms, and that's equal to 0.02 amps. Next you would do V equals 0.02 amps for V equals IR times 200 ohms, which equals 4 volts. Next you do Q equals CV, so 2.0 times 10 to the negative 6 farads times 4 volts, so Q is equal to 8.0 times 10 to the negative 6 coulombs. And that's it for the 2007 response question. Now the last question is the 2010 AP Physics B free response question, Form B. It says, in the circuit above, the battery of EMF epsilon is connected to 2 long straight parallel wires, which in turn are connected to 4 resistors with resistances given in the figure above. Assume that any other resistances in the circuit are negligible. Express all the algebraic answers to the following parts in terms of the given quantities and fundamental constants. A. Derive an expression for the total resistance of the circuit. Okay, so you have a parallel circuit and a series circuit. So first, you're going to want to do 1 over R2 plus 1 over R2 equals 2 over R2, which is equal to half of R2. Then you'll do R1 plus R1 equals plus half R2. So A is 2R1 plus half R2. Can't combine, and you can't combine them any further since they're not like terms. So B, derive an expression for the total power dissipated in the circuit. Well, P can equal to V squared over R, and this is also equal to V. So you'll have epsilon squared over what we just found for the total resistance to be, so 2R1 plus half R2 equals P. And that's it for that, part B. Now it wants In C, it says, assume that any magnetic field result only from the currents in the two long wires. C. What is the direction of the magnetic field, if any, at point P, which is in the plane of the page? Well, it will go out of the plane of the page and into the plane of the page, because the top wire causes it to go in, bottom causes it to go out. The bottom wire is closer to P, so force is greater. And that's it for that. Now D, what is the direction of the force, if any, on the bottom wire due to the current in the top wire? It'll go towards the bottom of the page and into the page. Into the page because the top forces it to. The top's current forces it to, and toward the bottom of the page because of the bottom wire. And that's it for the 2010 Physics B response question for me. That's it for this video. Thanks, guys.